All right, so we talked about doing a few examples, some more challenging than others. The first challenge problem that we have was 4a cubed b to the 3 to the exponent 2. And so what we said is there's two different rules here. First of all, we have a number of things inside brackets to an exponent. And so in our rule, ab to the exponent m is am and bm. That means that we apply the exponent to every item in that bracket. All right, so the 4 is going to go to the exponent 2. A cubed is going to go to the exponent 2. And b cubed is going to go to the exponent 2. Then our next rule is we see that we have an exponent within the exponent. And so our rule is we multiply the exponents together. So in this case, 3 times 2, 3 times 2, and then there's no exponents to multiply here, so we leave it as 4 squared. 3 times 2 is 6, and 3 times 2 is 6. Now our final step is 4 squared. We can actually get a number for that, right? That's 4 times 4, which is 16, and then we have a to the 6 and b to the 6. Now for this question, the challenge problem would be if we had 4a to the 3, and we also had a to the 4 in brackets, and then we had it to the exponent 2. So again, there's a number of ways you could start with it. First, you could recognize that in the inside, there's actually two of the same bases. A and A are the same base. And so when we have two of the same bases and we're multiplying them by each other, we add the exponents. So a m plus n. So here we're going to go a3 plus 4, which is going to equal a to the 7. We still have a 4 inside, all to the exponent 2. And now from here, we can use the exponent am and bm. We're going to bring that 2 to each value. Inside, we have 4 squared and a to the 7 times 2. Oops, sorry. A to the 7 to the exponent 2. And now a to the m times n. We multiply the exponents with the 7 and the 2. We get 4 squared, a to the 14. And final step, 4 squared gives us 4 times 4, which is 16. A to the 14th would be our final answer. Now, if we did the same type of question, but with division, all right, this same problem applies. A over b to the m means am over bm. So we're going to bring the 3 to every single item in this expression. So we have 5 to the exponent 3, a squared to the exponent 3, b cubed to the exponent 3 over 4 cubed, a cubed, and b squared to the exponent 3. And then we look and we see, well, we have an exponent to an exponent. And so we're going to multiply the exponents together. So here, the 5 cubed stays the same. There's nothing to multiply. 2 times 3 is 6. 3 times 3 is 9. 4 cubed stays the same. A cubed stays the same. There's nothing to multiply. And 2 times 3 is 6. And then what we notice is there's actually something else we can do. If you notice, we're dividing two bases that are the same. And so if we have the same base on the top and the bottom, we're going to use our rule am over an, and we subtract the exponents. So 6 minus 3 is going to be a to the 3, and 9 minus 6 is going to be b to the 3. If we were to expand it, we have 9 b's on top and 6 b's on the bottom. When we cancel out, we're left with 3 b's on top. For a's, we have 6 a's on top and 3 a's on the bottom. If we cancel, we're left with 3 a's on top. And then finally, the last thing to do would be to add in our numbers. And we know we can actually get answers for these too. So 5 times 5 times 5, which is 25 times 5, 125. A cubed, b cubed. And 4 cubed is 16 times 4, which is 64. And that is it, because there's nothing left over top. And that would be our final answer.